All. So welcome to Hack of the Day Part 8. Now I know it's been a while. I was traveling all over Europe for Black Hat and a bunch of other talks and trainings. So hopefully now I'm back and you should see a lot more videos. Though please be warned, I'm also planning for a long vacation. But I'll try to put as many videos as I can whenever I get time. Okay, so in this hack of the day, I wanted to introduce you guys to the power of Python, right? And what we are going to try and do is create a wireless SSID sniffer, which of course means wireless here is .11 networks, and write around 10 lines of Python code to create a sniffer. Now this free video is sponsored by Security Tube Trainings. We have a lot of fantastic online trainings available on Python, iOS, Linux, Wi-Fi, Metasploit. Please do take a look. Now, of course, when you talk about wireless sniffing, you're already thinking there must be some hardware requirements. And you're right. You would require or for that matter, any card which can sniff and inject traffic. I am going to be using the Alpha Networks AWS 036H for this video, right? So check on other cards and I'm sure you would find many. If you're totally new to wireless hacking, check out the Wi-Fi security mega primer which I put out. I think it's around 8 to 9 hours of videos on absolute simple to probably the most advanced attacks out there, at least known to me. Okay, so let me go back to my machine, and what I've done is I already have a monitor mode interface called Mon0 which has been created. And if all this is totally new to you, please check out the Wi-Fi security mega primer on Security Tube. Right now, what I'm going to do is in order to go ahead and create a wireless sniffer, one way of course is to write all the low-level code yourself. Now this is where a library called Scapy comes in, and it's actually a Python library. Now Scapy can be invoked directly in an interactive fashion, or you could even include it in your programs as a library and then unleash its power. So let me first go ahead and demonstrate what we want to do using Scapy in an interactive mode. So you can just type in Scapy after installing it. Backtrack, for instance, I think ships with Scapy, but you can check. Now the first thing, as you're probably imagining, is to tell Scapy the interface you would like to use for monitoring. So this can be done by first inspecting the current configuration with conf, and you'd actually see a ton of options in there. If you notice right now, the I face or the interface on which sniffing is going to happen by default is set to ETH0. We would need to set this to mon0. So conf.iface equals mon0. Right? Now, in order to sniff packets on mon0, it's pretty simple. Packets equals sniff. This is one of the API calls of Scapy. And you can just mention a count. Let's say count equals 5. Now when I hit enter, sniff will go ahead and start sniffing on mon0, and as soon as it gets 5 packets, it will return. Now packets contains really the array of all the 5 packets, and if you notice right now it says other is 5 simply because wireless features in here. Right? It's of course neither basic TCP, UDP or ICMP, even though internally of course it could carry all 3. And if you notice the number of packets which we have, 5, right? Now one of the ways by which you can quickly work with Scapy is by hitting packets.summary, and this would give you a summary of the individual packets in there. And if you notice, we can already see that we are seeing .11 beacon packets with an SSID Vivek in there, right? And there are a bunch of other packets as well. Now, if you're seeing, Scapy has already done all the heavy duty processing for us, right? Now let's move further and see what can be done. So let's say that we want to parse this list of packets and only print the ones containing beacon frames. So here is how you would do it. For packet in packets, I hit a space because in Python indentation plays a key role. If packet dot has layer, again escapee API call, and then you can basically say dot 11, and really what we've just checked right now is for dot 11 with has layer. Of course you could check for dot 11 beacon as well, but I'll try to do it in a different way, right? What I'm going to do is I'm going to put in the type and subtype of the packet manually. Now before all of that, let's try and understand the problem better. So all I'm going to do here right now is print dot 11 packet, which basically is all the packets, right? Here is what I'm going to do. I'm going to first visualize one of the packets, let's say the first one, as a PDF using PDF dump, and this is really going to go ahead and just a second. Oops, it has to be packets 0. Here you go. So we are going to inspect it using PDF dump, and this is fantastic because really escapee allows you to visualize the whole packet in this form. And if you can see, it basically tells you that it's a management packet, it's a beacon frame. Here is the type and subtype. The type for management is 0, the subtype is 8 for beacon frames. And if you notice, we have the dot 11 information element in here, and this one is SSID in specific and the SSID is Vivek, right? Fantastic. Now one of the other ways of visualizing the packet is also to use Wireshark real quick. So I'm going to select mon0, start sniffing, hit a stop, select the beacon frame with SSID Vivek, and I'm going to look at what's inside here, right? And if you notice, basically at this point the version for a beacon frame is 0, and the type basically version of course is going to be 0 for all dot 11 packets. Type of them is management frame, which is 0, and subtype is 8, which stands for the beacon frame, right? If you inspect the addresses, you would actually find that the destination address for beacon as expected is broadcast. The source address is really the AP's address, and the BSSID is also the AP's MAC address in this case, right? So this is ADDR 1, 2 and 3. So armed with this knowledge, let's go back to escapee and write this out, right? So conf.iface equals mon0, fantastic, packets equals sniff count equals 5, and if I do a quick packets.summary, actually see we have a bunch of them, and here is first one is actually a dot 11 beacon. So here is what I can do, right? For packet in packets, if packet has layer dot 11, which is it's an 802.11 packet, then check if packet dot type equals 0 and packet dot subtype equals 8, right? If this is the case, print beacon frame %s, and then we can actually do a packet dot addr2 packet dot info to get the SSID, right? And there you go. Now we are able to parse all beacon frames, and we output the BSSID or the AP MAC address in this case and the SSID. Now if you're wondering how we figured out the type and the subtype references in here, and all of this really, if you cannot recall, when we actually did the PDF dump, clearly mentioned here that type and subtype are two fields, and at the very same time info is what contains the SSID. And then you have ADDR123 to ADDR4, which contains the different addresses in the packet. Now, of course, you can also go through SCAPy's class documentation and figure out other minute details, which I leave to you, right? So now, let's go ahead and write this out in the form of a formal program which we can run. So here goes vim SSID sniffer.py user bin v python, and now we need to import the SCAPy library, scapy.all import star, right? Now the thing is that basically we'd like to inspect the whole packets as they are coming in live, which means if we use the sniff with the count in it, we'll have to wait till we sniff that many number of packets, right? Which is not really desirable. So instead we would want that we call a packet handler every time a new packet is received, and SCAPy makes this extremely simple to do. Here is how you're going to do it. You can call sniff, and of course in this case you would have to go ahead and mention an interface here. So let's say mon0, because now it's inside a script, and then you can actually mention a packet handler function, which let's call it packet handler, right? And then we can define the packet handler function here. The function receives an input, which is just basically the packet itself, right? So here is what happens. Now SCAPy continuously sniffs the air on mon0, and every time it finds a new packet, it invokes packet handler with it, right? Now inside this, we're going to run the exact same check we did right now. If packet.has layer.11, if packet.type equals 0, and packet.subtype equals 8, then we know it's a beacon frame. And at this point we can actually say print apmac %s with SSID %s, and then give these values to it, which is pkt.addr2 pkt.info, right? Now there are other ways to do it as well. I leave it to you to check on how it can be done. At this point, as you see, it's really not even 10 lines yet, right? Anyway, before I get all enthusiastic, let me ensure that this runs in the first place. chmod a+x SSID Sniffer.py. So run it, and if you notice, we are getting all the SSIDs, and there are APs for which there are null SSIDs as well, right? Now this is not very useful because I'm seeing the same AP over and over again, right? And at the very same time, I think if I use a tool like AeroDumpNG to cycle through channels, AeroDumpNG mon0, then I might actually start finding other SSIDs as well, as you can clearly see, right? Okay, so why not just convert this to print the list of unique SSIDs, right? And here my assumption is we're going to use the MAC address really for every unique AP. Okay, so this should actually be simple to do. Let's define a list here called AP list, and then let me go down here and do the quick check, which is we are checking if pkd.addr2 is already there in the list, right? And in this case, really, it's only if it's not in the list. Then we're going to do all the stuff, which is, first of all, let's add it to the list. And then let's go ahead and print this out. Right? Does this make sense? So now what we are doing is we are really checking if the address was seen previously. If it is seen, just add it to a list, and do not print duplicates really. So what is happening here is the very first time we find an AP with an SSID and a MAC address, we are basically going ahead and adding the MAC address to our list of APs. And the very next time we encounter it, really we don't do anything. But the first time we print the AP, MAC, and the SSID. Okay. Okay, let me do a quick check if this works. And as expected, now all you get is unique ones. Of course, you have a problem of the SSID being null here in some cases. And if you notice, that is causing some interesting things to happen. And there's an interesting solution to it, so I leave it to you. Try removing the null SSIDs yourself. It should be fairly simple. Note that each of these AP Macs are really different. Even though they look pretty close, they are really quite different. Right? Awesome. So this is how you can create a very simple wireless sniffer. Let me see if I was able to keep my word of doing it in 10 lines of Python. I could remove this line, and there you go, right? Exact 10 lines of Python, and you basically have an SSID sniffer to give you the list of unique SSID MAC combinations out there. Right? Cool. So this should hopefully illustrate the power of Python. Comments and feedback most welcome. I think you guys can post new scenarios which you want me to take up in Hack of the Day, and I can do that for you. Now, if you are interested in Python scripting and want to go ahead and look at things in a much more extensive, detailed, but methodical way, check out the SecurityTube Python Scripting Expert course and certification. And of course, if you want to look at Wi-Fi attacks and learn how to conduct attacks yourself, check out the SecurityTube Wi-Fi Security Expert course and certification. That's all for this video, guys. Thank you very much. Bye-bye.